Okay, good morning. So we're going to have a look at differentiation, all the grade 9 questions over the past few years. Okay? Now, you're going to look at this question first of all, and you're probably thinking, why is this question even a differentiation question? It's not a typical question that you'd see, and that looks like differentiation. So let's have a look at why this needs to involve calculus. So the diagram shows a solid cuboid. The total surface area of the cuboid is A centimetres squared, okay? So when I think about surface area of this cuboid, I know a cuboid has 6 faces. So surface area is going to be worked out by working out this face and multiplying it by 2. So we know that's x times 12 minus 3x, and I want 2 lots of that. Then I'm going to add the side face, which I'm going to multiply by 2 again. And this is also x lots of 12 minus 3x times 2. Plus, and then lastly, the last face is the top and the bottom, which is x times x. And again, we're going to multiply that by 2. This is how I'm going to work out the surface area. So I'm going to expand and simplify all of this to work out the surface area. So technically, these two are the same. So this is literally just going to be 4x lots of 12 minus 3x plus, and then we're going to have 2x squared. This is going to give me 4 times 12 is 48x minus 12x squared plus 2x squared. I'm going to have 48x minus 10x squared. Okay, so we know that the surface area of the cuboid is A. So we know that A equals 48 minus 10x squared. We've just worked that out. So how are we now going to find the maximum? Oh, sorry. It should be 48x. Sorry, that's a bit of a typo. 48x minus 10x squared. Yeah, 48x minus 10x squared is the surface area. How are we going to find the maximum value of A? We're going to differentiate A with respect to x. And then 48 minus 20x. Now, to find the maximum or minimum or the turning points, we know it's when our gradient function equals 0. So when does 48 minus 20x equal 0? That is when 48 equals 20x. So 48 divided by 20 equals x. So this is when x equals 2.4. Okay, that's a nice, easy 5-mark question. However, we haven't stopped there just because we found x. And this is one of the biggest mistakes people make, is that they find x, they stop. And what's the maximum value of A? We found them, when is the maximum happens? Is when x is 2.4, right? I now need to substitute that back into A. So A equals 48 lots of 2.4, bless you, minus 10 lots of 2.4 squared, which gives me 57.6 centimetres squared. Question 2. Now this is quite a nice question. I'd say it was one of the more typical ones that we've been seeing, isn't it? So step 1, differentiate. Okay, let's do this then. So who wants to tell me the first one?
3x squared.
3x squared, absolutely. And that's because we bring the power down, decrease the power by 1. The next one?
Minus 12x.
Minus 12x, brilliant. And minus 15, perfect. So this is really nice that we're able to get to the stage now. Nice few marks. Okay, let's have a look at this one. The curve with this equation has 2 stationary points. What does it mean if we have 2 stationary points?
A maximum, minimum.
Yeah, we probably have a maximum and a minimum, okay? And what do we know about if we have stationary points, turning points, maximum, minimum? It means the gradient function equals 0. So that actually means that 3x squared minus 12x minus 15 equals 0. So now I'm able to solve this because I have a quadratic, okay? So you can factorise this, you can use your calculator, you can use a quadratic formula. Straight away, I know. Now, if I want to, 3x squared minus 12x and minus 15 are all actual factors of 3. So if I divide everything by 3, I'm going to have x squared minus 4x minus 5. So now I'm going to have 3 lots of x and x. Two numbers that multiply to give me minus 5 and add to give me negative 4 is minus 5 and plus 1. This equals 0, so therefore x equals 5 and x equals negative 1. Okay? I factored 3 out of all of this. I divided everything by 3. Just to make it easier for me to factorise.
Yeah, but why would you put 3 in? Like...
So now I have my coordinates for x. How am I going to find my coordinates for y? Yeah, I'm going to substitute it into the original equation. So the original equation is y equals something cubed minus 6 lots of something squared minus 15 lots of something. Okay, it's right here. And instead of writing x's, I'm writing this. Okay, so I'm going to substitute it, back in. And this is like, you know, when we solve simultaneous equations, it's like the second part of it, you know. Okay, so the first one, I'm going to substitute in 5. Okay, when I substitute in 5, I'm going to get y equals, so 5 cubed. Now remember, always use these brackets because your calculator sometimes does not understand, it does understand negatives, however it processes them slightly different. So I get minus 100. Okay? So that means this coordinate, my first coordinate, is 5 minus 100, because it wants coordinates, and we know coordinates are in brackets. Okay, now when I substitute in minus 1, okay, I'm going to make sure, again, I have my brackets. It's really important that you use brackets when substituting into a calculator. So your calculator sometimes gets confused and does the indices first. So, and then I get 8. So minus 1 and 8. So when I substitute in minus 1 here. And if you think to yourself, oh, I don't need to substitute, use brackets. Well, minus 1 squared. We know that minus 1 times minus 1 is a positive number. We know any square number is always positive. However, if you type minus 1 squared into your calculator, it's going to give you minus 1. And that is because your calculator has done BIDMAS, essentially. It's done the indice first and then used the minus 1. If you want to let it know that really what we're doing is minus 1 and then we're squaring it, then it will give you 1. Okay? So please, please, please remember that. Okay, again, so a nice, easy, I don't even know how many marks was this question? 6 in total. 6 in total. Really easy. Okay, question 3. The diagram shows a cuboid of volume v centimetres cubed. Show that the volume equals this. Okay, how do we find the volume of a cuboid?
Just multiply all the sides.
Yeah, we're going to multiply all the sides together. So we know we're going to have 2x plus 5 multiplied by 3 minus x multiplied by x plus 1. Okay, this is what the volume equals. Now, we know that when we multiply, I'm going to multiply the first 2 first. These 2. And then I'll multiply it all by x minus 1. So 2x times 3 is 6x. 2x times negative x is negative 2x squared. 5 times 3 is plus 15. 5 times minus x is minus 5x. This all then needs to be multiplied by x plus 1. However, I'm just going to tidy it up slightly, okay? And again, you could do this a different way, and that's completely fine. So I'm going to have minus 2x squared. 6x minus 5x is x plus 15. And I'm going to multiply all this by x plus 1. Now, however you decide to do this next bit, it's completely fine, but you do have to show each step because it says show that. And if you ever have a show that question, we need to make sure we're showing each step. So you might have multiplied yours slightly different, that's fine. I'm going to do 2x times x squared. So that's minus 2x cubed. 2x times 1 is minus 2x squared. I'm now going to do x times x is plus x squared. X times 1 plus x. I'm then going to do 15 times x is 15x. 15 times 1 is 15. I'm now going to simplify. Minus 2x cubed minus x squared plus 16x plus 15. Okay, now they've actually written it this way, so I'm just going to go ahead and rewrite it. So v equals 15 plus 16x minus x squared minus 2x cubed, therefore shown. Okay, so I've shown all of my steps. Remember, this is 3 marks. Now you might think, oh my god, this is, this question is always at the back of the paper. Okay, always go through, because even if you don't understand how to do differentiation, you can all expand brackets. Everyone can expand triple brackets. Amazing. It now says there is a value of x for which the volume of the cuboid is a maximum. So there is a value where this is a maximum. If this is a maximum, what do we know about maximums?
The gradient is 0.
The gradient function equals 0. So that means the differential of the volume with respect to x equals 0. And then it says give your answer correct. It says find the value of x and give it correct 3 significant figures. So we know that v equals 15 plus 16x minus x squared minus 2x cubed. Okay, so I'm going to go ahead and differentiate v with respect to x. 15 differentiates to?
0.
0. 16x differentiates to?
16.
Minus x squared?
2x.
Minus 2x. Minus 2x cubed? Minus 6x squared. Absolutely. Okay? Now, this is now going to equal 0. And I can now solve this quadratic. Now, how you choose to solve this is up to you. Okay? We should be at a stage where we can factorize.
You can take the 2 out.
Yeah, we could factorize out 2, couldn't we? To make our life easier. So if I factorize out 2, I'm going to get 8 minus x minus 3x squared. Okay? So I know I'm going to have 2 lots of, I'm going to have x and a minus x, aren't I? Because we know we have to have a negative x, right? So, however, we know that one of them is going to have to be a 3. So let me just put the 3 here, the minus 3x. We know, because obviously x times x is just x squared. We need a minus 3x squared, right? And then 2 numbers that multiply to give me 8.
Join 4.
No, but they give you
But they have to...
Yeah, 6. Minus 1. Minus 1.
Okay, so then we do this, and then do you know what we realised? I'm trying to help you factorise this. It wants to answer correct 3 significant figures, so I'm telling you now it's not going to be a nice number. Okay, so we have 2 options now. We can use the quadratic formula, okay, or we can use our calculator with our A being minus 6, our B being minus 2, and our C being 16. And I'm going to have x1 equals minus 1 plus root 97 over 6. Okay, which equals 1.47480 dot dot dot. Or my x2 is minus 1 minus root 97. Again, you can use the quadratic formula for this. And I'm going to get minus 1.80814 dot dot dot. Now, thinking about this, which value of x are we going to use?
Just going to put both of them.
We're not going to put both of them. We're going to put the positive one, because if we had x plus 1, if this was negative 1.8 plus 1, we'd get negative 0.8, right? We can't have a negative length.
Yeah.
You either have 0 length or positive. So we're going to take the positive. So we reject the negative. Okay, and the positive to 3 significant figures is 1.47. And there we have 8 marks. Question 4. A solid S is made from a hemisphere and a cylinder. The centre of the circular face of the hemisphere and the centre of the top of the face of the cylinder are the same point. So this basically just says that they both have a radius that's the same. And in this case, our radius is X. Brilliant. And if we look at the diagram, the radius of the cylinder and the radius of the hemisphere are both X. That's what it's just told us. The height is 20 minus 4X. The height equals 20 minus 4X. The volume of S is V centimetres cubed, where V equals 1 over 3 pi Y. Find the maximum value of Y. Okay, so first things first. They've given us the volume. However, we also have a formula for the volume, right? So our formula for volume is volume of a cylinder is pi r squared h plus the volume of a hemisphere. Now this is given to us in the formula sheet. Okay, so you notice when you do an assessment, at the front of your paper you have a formula sheet. Plus 4 over 3 pi r cubed. However, this is for a whole sphere, we have half a sphere. So we're going to divide it by 2, right? So, let's work this out then. So, our volume equals pi times, now what is our r? Yeah, x squared, and what is our h?
20 minus 4x.
20 minus 4x. Plus, now 4 over 3 divided by 2 is 2 over 3. 2 over 3 pi times x cubed. Okay? Now, if I have a look, they've given us the volume as a third pi y. So I'm going to take out a third pi. I'm going to expand this side first. So pi times, so pi x squared times 20 is 20 pi x squared. Pi x squared times minus 4x is minus 4 pi x cubed. And then we have plus 2 over 3 pi x cubed. Okay, so now our volume is 20 pi x squared. Now what is minus 4 plus 2/3? So minus 4 plus is going to give me minus 10 over 3 pi x cubed. So now what I need to do is put it back into the form. So V equals a third pi lots of something. So I need to factorise this. If I take a pi from both sides, everyone's happy? Mm-hmm. Now, if I take a third out, a third times what equals 20?
60.
Yeah. So this becomes 60x squared. And a third times what equals minus 10 over 3? Minus 10. Minus 10x cubed. Now, if you're unsure if you're right, expand this out and check that you're getting 20 and minus 10, yeah? A third times 60 is 20, yes. A third times minus 10 is minus 10 over 3. So now factorise this. So now, technically, I know what my y is. Okay? Wants us to find the maximum value of y. But y is 60x squared minus 10x cubed. So we need to do dv by dx. Okay, so we can do it with our normal v here. So let's differentiate this. So bring the power down. 40 pi x. Bring the power down. Minus 10 pi x squared. Okay, what does this equal? It equals 0, because if we're finding the maximum or minimum. So 40 pi x equals 10 pi x squared. Okay? Well, sorry, it's minus 10 pi x squared equals 0. I skipped a step. And then what we're going to do, we can divide both sides by pi. We can divide both sides by x. So I get 40 equals 10x. So 40 divided by 10 equals x. What does x equal? 4. So now to find the maximum value of y, I just need to substitute y into this part here, because this is what y equals, doesn't it? So I'm going to get 60 lots of, remember, because y equals 60 lots of 4 squared minus 10 lots of 4 cubed. Because our y, we've made it the same. Okay, we've equated this. So now, 60 times 4 squared. Remember, we're going to use brackets. I mean, brackets aren't as much necessary when we have positives. However, when in doubt, get your brackets out. And I'm going to get 320. So the maximum value of y is 320. Okay, question 5. Curve C has this equation. Find dy by dx. Okay, so dy by dx equals. So bring the power down. 3 times a third is 1. And then decrease the power by 1. And then minus 9x to the power of 1. Bring the power down, decrease the power by 1. So I'm going to get x squared minus 9. Yeah? Perfect. So that was nice and easy. 2 marks, wasn't it? Then it says, find the range of values of x for which C has a negative gradient. So that means our gradient function needs to be less than 0. Because that's negative, right? So that means x squared minus 9 needs to be less than 0.
So it's an inequality now.
It's an inequality now, because we want, where is the gradient negative? The gradient is negative when the gradient function is less than 0. Now, x squared minus 9, I know is a difference of 2 squares. So this is saying when x minus 3 and x plus 3, where is this less than 0? Okay? So, I have 2 values. I have when x equals 3 and x equals negative 3. Now, if I was to sketch this graph, quickly. It's my x, my y. Okay? My graph is going to look something like this. It crosses here at 3 and at minus 3. And we know my y-intercept is minus 9. Everyone should be happy sketching this, right? Remember, I'm just sketching the gradient function here. Now, where is this graph less than 0?
For the x or
It's in between these 2 values, right? So that means the answer is the range of values for which x, it's between minus 3 is less than x is less than 3. That is where it's less than 0. Okay, it's in between here. If it said greater than 0, we'd have 2 separate inequalities. Okay? It always helps to draw the graph on these types of questions to figure out what's happening. Now remember, we're drawing the graph of the gradient function. We're drawing this quadratic graph here. Okay, question 6. So a particle is moving along a straight line that passes through the fixed point A. The displacement s meters of p from r at time seconds is given by this. Find the value of t for which the acceleration of p is 3 meters per second squared. Okay, so step 1. To find acceleration is the differential of velocity over time. Okay? To find velocity, we need to differentiate the distance over time, essentially. Okay, so we're going to start with that first. So, ds by dt equals 3t squared minus 12t plus 5. Now, this is what equals our velocity. So to find acceleration, I need to differentiate this again. So dv dt equals 6t minus 12. So find the value of t when the acceleration is free. So that means 6t minus 12 equals 3. Okay, don't just go ahead and substitute numbers anywhere. Figure out what it wants. It says find t. So 6t equals 15. T equals 15 over 6. So this is 5 over 2, which is 2.5. There we have it. Nice, easy, 4 marks. Okay, question number 7. It says the curve C has equation y equals x squared minus 6x plus 4. Using the axis below, sketch the curve C on your sketch, showing clearly the exact coordinates of any points of intersection of C with the coordinates axes and the turning point. Okay, so we can do this question in multiple ways. So first of all, if we try to factorise x squared minus 6x plus 4, I realise that I don't know two numbers that multiply to 4 and give me and add to give me negative 6. I mean, if I had negative 4 and negative 1, that would give me obviously positive 4. However, it's not going to give me negative 6. So I can use my calculator to help me. However, I can start first by actually finding the turning points, which could be quite easy. Now we can do this two ways. We know that we can complete the square, so we're going to have x minus 3 squared minus 9 plus 4 is minus 5. Okay, so I know my turning point is 3 minus 5. Or we could differentiate, which is why this is in the differential. If we differentiate y with respect to x, I get 2x minus 6. And I know 2x minus 6, when this equals 0, I'm going to get my turning point. My maximum or my minimum, in this case it's going to be a minimum, so 2x equals 6, x equals 3. I can substitute 3 back into this equation and I will get negative 5. Okay, so you can see there's the two ways to do this. So I know it's going to be a minimum at 3 minus 5, which is roughly here. I also know that I'm going to cross the y-axis at 4, because this is my y-intercept. Okay, now what I don't know is if I'm going to have a negative here or a positive. So I am going to use the quadratic formula to find my solutions for x. Okay, so x squared minus 6x plus 4 equals 0. So my a is 1, my b is negative 6, and my c is 4. However, failing this, if I wanted to do this another way, so I can put this in and I'm going to get some answers. Or, I've already completed the square here. So I know this is the same as when does x minus 3 squared minus 5 equals 0? Well, this is when x minus 3 squared equals 5. So x minus 3 equals plus or minus the square root of 5. So x equals 3 plus or minus root 5. So root 5 is roughly 2.23. So we're going to have x equals 5.23 and x equals 0.76. So we know that they're both positive. So when we're sketching this graph now, okay, we know the points are going to be roughly here and here, and it is going to be symmetrical about our turning point. So when we sketch our graph, if you have to sketch this a few times, that's okay. Should look something like this. Now what I suggest you do is, it does say the exact coordinates in all the coordinates. So I know we've written them in decimal form. However, make sure that when you are then labeling the graph, you are writing 3 plus root 5, comma 0, and this one is 3 minus root 5, comma 0. Okay, you should have, and even that we've put 4 here, it said coordinates, and just writing 4 is not a coordinate, writing 0 for is. So there we have it. It's a 6-mark question, so you would be expected to have 1, 2, 3, 4 coordinates and the graph correctly drawn in pencil, and then you'll probably get a method mark somewhere else. So there you have it, nice and easy. Okay, question 8. It says the point A is the only stationary point on the curve with equation y equals kx squared plus 16 over x, where k is a constant. Given that the coordinates of A are this, find the value of A. Okay, first of all, y equals kx squared plus 16x to the negative 1, because this is in index form. If it says the point A is the only stationary point. What do we know about stationary points? The gradient function equals 0. So this means dy by dx equals 0. So kx squared plus 16x to the negative 1 equals 0. No, sorry, I haven't differentiated yet. Sorry, guys. So let's find dy by dx. So we're going to have 2kx minus 16x to the negative 2. Now this equals 0. So 2kx minus 16 over x squared is the same thing. This equals 0. So I'm going to have 2kx equals 16 over x squared. If I multiply both sides by x squared, I'm going to get 2kx cubed equals 16. So x cubed equals 16 over 2k. X cubed equals 8 over k. So x equals the cubed root of 8 over k, which we know is x equals 2 over the cubed root of k. Okay? It tells us the coordinates are 2, 3, and a. So the coordinates is 2 over 3, a. So that means x equals 2 over 3. So 2 over the cubed root of a number equals 2 over 3. So this tells me that the cubed root of k equals 3. So k equals 3 cubed, which is 27. So k equals 27. Now that we know that k equals 27, that means that y equals 27 lots of x squared plus 16 over x. If I substitute in my 2 over 3, I'll be able to find my y coordinate. So it's going to equal 27 lots of 2 over 3 squared plus 16 divided by 2 over 3. I'm literally going to put that in my calculator exactly how it looks, which gives me a value y equals 36. So therefore a equals 36. Again, another nice and easy 5 marks, especially when you know what you're doing and how to translate these words into what's happening. Most of the skills here is just rearranging equations and solving. Question 9. This is the last question that we have today. So, a particle is moving along a straight line at the fixed point O lies on this line at time t seconds where t is greater than or equal to 0. The displacement s meters of p from O is given by this. Find the displacement of p from O when p is instantaneously at rest. Okay, so the first thing we need to do is differentiate s with respect to t, because this is going to give us our velocity. So we're going to have 3t squared plus 10t minus 8. Now, when it wants a displacement when it's instantaneously at rest, that means the velocity is 0. So we're going to have 0 equals 3t squared plus 10t minus 8. So I can factorize this. I'm going to have 3t minus 2 plus 4. Okay, I'm just going to double check that. I know I'm going to get my 3t squared. Minus 2 plus 4 is negative 8. So minus 2t, and then 3t times 4 is 12t minus 2t is 10t. Yeah, perfect. So I've done this correctly. So t equals 2 over 3, or t equals negative 4. Well, first of all, there's a few things. We're going to reject negative 4 for a few reasons. Number 1, it tells us in the question. Okay? But number 2, we also can't have a negative time. Okay? Time is positive. Okay? We can't go back in time. So our t equals 2 over 3. And what it wants us to do is to find the displacement of p. I'm now going to substitute this back into our equation s. So we're going to have 2 over 3 cubed plus 5 lots of 2 over 3 squared minus 8 lots of 2 over 3 plus 10. This is going to give me 194 over 27, and this is going to be in meters. So again, another easy question. Probably the hardest part of this question is figuring out what we actually have to do. Okay, thank you for watching. Remember to subscribe to Mindful Maths, and good luck with your upcoming exams. Have a great day.